in the chapter Numerical Methods. It is numerical integration. Now in this case, in this numerical integration, we can find an approximate value of the integral to be fx dx. And there are two methods in the syllabus. One is the trapezoidal rule and another is Simpson's rule. That is to find the integration, the value of the integral to be fx ds using numerical methods. Okay. Now first case is trapezoidal rule. Consider this trapezoidal rule. Here we have to integrate the function y equal to f of x with the limit a to b. Here also we divide this ab, that is the interval ab, into different partitions, and starting from x0, again in the previous cases we consider h is a small value, and x0 plus h is x1 plus h is x2, like that up to b. Suppose there are xn equal to b. So that means we partition the interval ab into n parts, and the points are x0, x1, x2, etc., xn. Okay, and the corresponding we have then naturally the corresponding values of y are taken as y0, y1, y2, etc., yn. And then this trapezoidal rule, the formula is integral a to b fx dx is equal to h by 2 into y0 plus 2y1 plus 2y2 plus etc. 2yn minus 1 plus yn. This y0 and yn are having coefficient 1. All the other have coefficient 2. Okay, and it is denoted by the letter t. Normally trapezoidal rule, trapezoidal, the formula integral a to b fx dx, the value is denoted by t, and so we have the formula t is equal to integral a to b fx dx. It is equal to h by 2 into y0 plus 2y1 plus 2y2 plus etc. 2yn minus 1 plus yn. y0, y1, y2, etc. are the values of the function when x equal to x0, x1, x2, etc., xn. Okay. Now consider next one topic is that error estimate. That is, it is the error means it is the difference between the actual value and this approximate value. We calculate the approximate value using this numerical method, numerical procedure, and also we can find the integral directly. It is integrate and putting the upper limit and lower limit, we get a value, and the difference between this actual value and this approximate value, that is known as error. And also there is a direct formula in this trapezoidal rule. Always the error, that is the modulus of the error, it is denoted as e suffix t, that is error in trapezoidal. It's hence the notation et. It will be always less than or equal to b minus a by 12 into h square into a. Okay, and here b, a and b are the limit of integration a to b, b minus a by 12, h is that increment, that is x0 plus h, like that h, so that small value, and m means it is the upper bound of this modulus f double dash x. That is the second derivative, f dash and f double dash, find out f double dash, and if we put the values from a to b in this f double dash, what will be the maximum or upper bound, and that number is taken as m. Okay, then so the error approximate, the formula is modulus of this et, error will be less than or equal to b minus a by 12 h square m. Now consider an example. Using this trapezoidal rule with n equal to 4, evaluate integral 0 to 2 1 by 1 minus x dx. Now given that n equal to 4, and also we have this h is equal to b minus a by n, and hence it will be b minus a. Here the limit is from 0 to 2, so 2 minus 0, that is 2 by n is equal to 4, so 2 by 4, that is 0.5. Here we have h is equal to 0.5, and x0 is equal to 0, and here x4, n equal to 4, so x4 is equal to 2, and the intermediate values are x0 equal to 0, then adding this h 0.5, adding we get x1 is equal to 0.5, x2 is equal to 1, x3 equal to 1.5, and x4 is equal to 2. It is, we have to divide this interval 0 to 2 into 4 equal parts. That is the meaning of this. N equal to 4 means. So each interval will be of width 0.5. That means that is h. H is equal to 0.5. So first of all, we find this x0, x1, x2 and x4, x3, x4 and corresponding values of y. Y means when x equal to x0, well, what will be y? Put the value x0 in the given function. We have the function is 1 by 1 plus x. So y0 means 1 by 1 plus x0 is equal to 0. So 1 by 1 plus 0. That means 1. So we have y0 is equal to 1. Now y1. y1 is equal to 1 by 1 plus x1. We have x1 is equal to 0.5. So 1 by 1 plus 0.5. And by simplifying, we get it as 2 by 3. And next is y2. y2 means 1 by 1 plus x2. x2 is equal to 1. So 1 by 1 plus 1, it is 1 by 2. And y3, 1 by 1 plus x3. x3 is 1.5. So 1 by 1 plus 1.5 means 1 by 2.5. That will be 2 by 5. And lastly, y4. y4 means 1 by 1 plus x4. Here x4 is equal to 2. So 1 by 1 plus 2, that is equal to 1 by 3. So we have this y0, y1, y2, y3 and y4. Now from these y1, y2, y3 and y4, we have this t, the approximate value. The formula is h by 2 into y0 plus 2, y1 plus 2, y2 plus 2, y3 plus y4, and substituting h is equal to 0.5. So 0.5 by 2 into 1 plus 2 into y1 is 2 by 3 plus 2 into y2 is 1 by 2 plus 2 into y3 is 2 by 5 plus y4 is 1 by 3. And hence the answer is 1.1167. It is the approximate value of the given integral. Okay. Then now to find that error. Here to find the upper m. M is the maximum of modulus of f double dash. Now we have the function is 1 by 1 plus x. So first derivative f dash will be minus 1 by 1 plus x whole square. And next derivative, second derivative will be again differentiating this. We get 2 by 1 plus x the whole cube. And in this, what will be the maximum? That is, if we substitute x equal to 0, etc. up to 2. In between 0 and 2, what will be the maximum value of this f double dash? Because here x is in the denominator. That means when x increases, the value decreases. So to find maximum means for f double dash will be maximum when x equal to 0, the minimum value. So putting x equal to 0, we get 2 by 1 plus 0 whole cube means 2. 2 is the maximum of this f double dash. So m is equal to 2. M is equal to 2. And we have the formula, this ET. Modulus of ET is less than or equal to b minus a by 12 h square m. That means less than or equal to b is 2, a is 0. So 2 minus 0 by 12, h is 0.5, 0.5 square and m we have 2. So substituting this, we get the value as 1 by 12 and that means 0.0833. That means the error is less than or equal to 0.0833. The meaning is that with the difference between the actual value and this calculated value, the difference is very small, that is it is less than 0.0833. So that is error. Okay. Now consider another example. Find the minimum, another type of example, find the minimum number of subintervals needed to approximate the integral given below using this trapezoidal rule. With an error and given that the error of the magnitude is less than 10 raised to minus 4. That means the integral 0 to 3 root of 1 plus x dx. Now after calculating the approximate value, the error must be less than 10 raised to minus 4. Then what will be the value of n? It is find the number of minimum number of subintervals. That is, we have to find n. How many intervals are there? We have to find n such that the error is less than or equal to 10 raised to minus 4. Now a is equal to 0, b is equal to 3 and we have f of x is equal to root of 1 plus x. So f double dash, first of all f dash is 1 by 2 root x means 1 by 2 into root of 1 plus x, and again second derivative f double dash x means minus 1 by 4 into 1 plus x raised to 3 by 2. Here also x is in the denominator, so as x increases the value decreases. So this f double dash x will be maximum when x is equal to the minimum value, that is 0. So putting x equal to 0, we get the value as minus 1 by 4, and taking the modulus, it will be 1 by 4. So m is equal to 1 by 4. Now we have h is equal to, by formula it is b minus a by n, and we have b minus a is 3, so 3 by n. Now substituting in the formula, in the error is less than or equal to b minus a by 12 h square m. That means b minus a, that is 3 by b minus a is 3, so 3 by 12, and h is we have 3 by n, so 3 by n the whole square, and m is 1 by 4, and simplifying we get it as 9 by 16 n square. But given that it should be less than 10 raised to minus 4, so we have 9 by 16 n square is less than 10 raised to minus 4. From this we can write n square will be greater than 9 into 10 raised to 4 by 16, and hence n will be greater than 75. So the minimum number, n is an integer and should be greater than 75, means the minimum possible n will be, the answer is n is equal to 76. Two exercises. Try to find integral 1 to 2x dx and integral minus 1 to 1 x square plus 1 dx by taking n equal to 4. Thank you.